very, very abstract, very high-level description. It's basically like a fancy tablet, you could say, right? They were locked though, so not of much use. Then we found some drawers, and as you could expect, we of course had a bit of a look at the files there, and of course there were clear text credentials to that HMI, so we could unlock it. That was pretty cool. Then we noticed there was also a printer, and we noticed that the network cables and ports were color-coded. And we noticed that that printer had the same color coding with its network cable and port as the HMI had. So since the HMI needs to be connected to the OT network, that might mean that then also the printer is connected to the same network. So why not try and plant our rogue device here? But we figured, okay, maybe they might have some network access controls here, so let's do it in a somewhat clever way. So we assumed that this is the setup. You have your printer that then authenticates towards the switch, and the switch, once successfully authenticated, would open that port for the printer to then reach the network. Cool. What did we do? Super simple. Again, Raspberry Pi to the rescue with 2 Ethernet interfaces. We bridged the connection. And then using Silent Bridge, for example, we had a transparent bridge. We would then assume the IP and the MAC address of the printer and would then be looking the same to the switch and to the remaining network infrastructure as the printer would. Super cool, super simple. Now, interestingly enough, I didn't really think about that beforehand, but I think the Y team already disclosed that this would work, and I was surprised that it did. We again had an LTE modem, underground, in a mountain. I didn't expect this to work. It worked brilliantly. So we had, again, connection via our cloud infrastructure to our C2 server, right? So that worked. And then the cool thing is, once we had this installation in place, we could then also remotely pretty much inject packages into the network.